Hello student, welcome to our channel 361 Physics. In today's discussion, we are going to talk about some numerical questions from alternating current. In the previous discussion, we already talked about the general discussion, that is theoretical part, as well as the MCQ questions from this chapter. So let us begin our discussion from here. So in particular discussion, we have 10 sets of questions. I believe these questions constitute the general understanding of cracking the numerical question that might be very useful for your board examination as well. So particularly, I have prepared this video for NEB examination, or and this video will be much useful for those students who are going to uh, attempt the final examination in 2080 BS of NEB. So let us begin the discussion. So first question, talk about the um, current and power dissipation along with some other idea. Okay, so in here, uh, the electric mains 220 volt and 50 hertz, okay, are connected to a resistor of 50 kilo ohm. Okay, we should be very careful about this kind of information. Find the current as the function of time. Okay, so we have to find the current as a function of time. So there is some error in the question typing. Okay, and the second is the effective current that we have to find. So most of the time this effective means RMS. Okay, so we have to be very careful about this one, and the power dissipation. So we will be calculating these things thoroughly. So in the uh, first part, we will be writing the information that we are provided with, that is the voltage that we are given is 220. If it is not said anything about the questions, then we have to understand this is RMS. यदि हामीलाई भनेरै दिएको छ भने चाहिँ हामीले त्यसलाई पिक लिन्छौँ या अरू कुनै लिन्छौँ। यदि केही भनेको छैन भने त्यो चाहिँ हाम्रो सिधै के हुन्छ त RMS हुन्छ. सो दिस इज योर RMS voltage. त्यसै गरी फ्रिक्वेन्सी हामीलाई प्रोभाइडेड छ 50 हर्ज. ओके, सो अब हामीलाई अरू इन्फर्मेसन दिएको छ रेसिस्टेन्स, द्याट इज 50 into 10 power 3 ohm. ओके, सो द करेन्ट एज अ फङ्सन अफ टाइम, यसको लागि हामी के गर्छौँ भने हामीलाई थाहा छ यसको करेन्ट एज अ फङ्सन अफ टाइम लेख्नको लागि हामीलाई जेनरल इक्वेसन थाहा छ. ओके, लेट मी जस्ट राइट we know the general formula of current is I equals to I naught sin omega t. Okay, हामीलाई यो थाहा छ, तर हाम्रो इक्वेसनमा I naught पनि छैन र ओमेगा पनि छैन. सो हामी यही बेला अब के गर्छौं, यो इन्फर्मेसनबाट since I naught is always equals to root 2 times V, I RMS. Okay, so I RMS, हामीलाई RMS भ्यालु थाहा छ भने RMS भ्यालुलाई मल्टिप्लाई गर्ने, रुट 2 ले मल्टिप्लाई गर्ने हो नि यो I naught आउँछ, पिक भ्यालु, किनभने हामीले थाहा छ. लेट मी जस्ट नोट डाउन द इन्फर्मेसन. दिस I RMS equals to I naught by root 2. Okay, similarly VRMS equals to V naught by root 2. These informations are well known to us. Okay, from there only I have just mentioned. Okay, अब यसलाई सल्भ गरौँ. जस्तो I naught को भ्यालु निकाल्ने छ भने यति गर्न सकिने भयो, or I naught equals to root 2 into I RMS means VRMS divided by R, because current is the ratio of voltage to resistance from Ohm's law as well. So if you simplify these things, then you can easily get this magnitude is very close to 311 volt. Okay, oh sorry, voltage is VRMS is VRMS is 220. Okay, so we have to calculate this VRMS. Okay, okay, so VRMS is 220 and resistance is there. So peak value of voltage is going to be 311, and so okay, the current magnitude might be a bit different. So if we calculate, then this quantity will come a certain amount. Okay, so the root 2, this is 1.41 into 220 divided by 50 into 10 of power 4, or 5 into 10 of power 4. So if you just simplify, then you will be getting some value of current as a some ampere. And similarly, you will be calculating another information, that is omega. And we know, again, we have the information of omega. Omega equals to 2 pi f. Okay, so 2 pi is there, no problem. And f is how much? F is 50 hertz. Okay, so f is 50 into 50, that is your 100 pi. Okay, so 100 pi. So if you just multiply, this is going to be nearly 314 radian per second. So therefore, our final answer for this question is I equals to, this would come in the order of, let's say, milliampere. Okay, 10 power 4 answer, you know, and 10 power 2 sir. Okay, 10 power some milliampere, it comes about some milliampere. So if you just multiply, I have calculated this value so far, it is in the order of 6.2 milliampere. Okay, so this is what your 6.2, and then sine omega means 314. Okay, let me just write in there. Okay, fine, 314 rad per second. Okay, and this whole information will come in terms of milliampere. This is our current. Okay, so this is the idea. Now another information, another calculation that we have to do is the effective current. So effective current we already got. This effective current IRMS will be equals to VRMS divided by the resistance. Okay, so this is so simple. And power dissipation. So finally, power equals to I square R. Okay, so here we have RMS value, so I RMS square into R. So if you just supply these calculations, then this would come in the order of uh, let's say 220 divided by 50 into 10 of power 3. It would come in the order of some milli ampere. Okay, so k milliampere आउने then यसलाई multiply गर्ने. So I RMS square into 5 into 10 of power 4. So if you just multiply, I have calculated this value. This will come in the order of, so very close to, this is 1 watt. Okay, so this is 1 watt. So this is how we can simplify the numerical. So let us move on to question number 2. Just before that, let me clear this frame. Okay, so okay, and just for a while, let me erase the information clearly. Okay, and then I will continue second. Okay, in the second one, solution for second number. So this is a 44 millihenry inductor. Okay, we have a inductor of 44 into 10 of power minus 3 Henry. Is connected to 220 volt. It should be 220 volt there. So this is your VRMS equals to 220 volt, and the frequency is again 50 hertz. Right, calculate the value of current in the circuit. This is quite simple type of problem. So in here we have inductor. So obviously if we pass the electric current, AC current from inductor, then it produces a kind of resistance that we call inductance. So inductance निकाल्नको लागि हामीलाई थाहा छ inductive reactance. So यो reactance ले resistance जस्तो behave गर्छ. This is XL is equal to omega L. Omega means again your 2 pi F into L. L is provided to us. So if you just substitute these parameters, then you will be getting some ohm. Okay, so this will be some ohm. Okay, 2 pi into frequency is 50 and so on. Now, what we have to do is we have to calculate the RMS value of current. So to calculate RMS value of current, simply what we do is, okay, we do the general calculation. IRMS will be equals to V RMS divided by resistance, and the resistance in here is simply XL. So this kind of question can be asked for 2 marks. Short type of problem are there. Okay, so similarly, if you simplify these informations, then the value for this one will come in the order of, okay, in the order of 16 ampere. Okay, so this is your 16 ampere in the order only. Okay, so let us move on to another question. That is question number 3. Okay, so in question number 3, some information are given to us. Let us summarize the information. That is, capacitance is 60 into 10 power minus 6. This is microfarad. Okay, and the voltage that we are given is 110 volt. Okay, and the frequency is something else than the previous 60 hertz. Supply, calculate the RMS value of current in the circuit. Okay, this is again similar kind. So IRMS will be equals to VRMS divided by resistance. But in particular case, this is a capacitor, so it will have XC. Okay, and this is your VRMS divided by XC means 1 by omega C. Okay, so if you multiply all these things, your IRMS is going to be VRMS into omega into C. So this is your VRMS into 2 pi f into C. So if you multiply all these parameters, then this is going to be in the order of, let's say, I've calculated all these order. So this is 2.5 ampere. Okay, so this is the information for question number 2 and question number 3. These question 2 and 3 are so short, that's why this might be asked in 2 marks. Okay, okay, so let us look at question number 4. So some informations are given there. So let me summarize the information of question number 4. So a 200 kilometer long telegraph wire. Okay, length equals to 200 into 10 power 3 meter. Okay, and the wire has a capacity. Capacity means it has some kind of capacitance. Okay, C equals to 0.014 into 10 power minus 6 farad per kilometer. Okay, so this is given in kilometer. This is also in kilometer. So I believe it's a per kilometer. That's why I wish to keep all the information in terms of kilometer, so that I believe this calculation would be a bit easier. So I will just write this much kilometer. Okay, so is your kilometer and 10 to the power 6 per kilometer. That's why overall capacitance, let me just write with C dash. This is L into C. Okay, 1 मिटरमा यति हुन्छ भनेको छ भनेपछि 200 किलोमिटरमा त अभियसली 1 किलोमिटरमा यति हुने, 200 किलोमिटरमा त अभियसली हामीले मल्टिप्लाई गरेर निकाल्नु पर्छ। त्यसैले यो भयो 200 into 0.014 into 10 power minus 6. Okay, farad only. अब हाम्रो किलोमिटर क्यान्सल भएर जान्छ, यति भयो। क्यापासिटेन्सको भ्यालु हामीलाई थाहा भयो C dash. Okay, so further it carries alternating current of frequency 50 kilohertz. Okay, sorry, 5 kilohertz. So frequency equals to 5 into 10 power 3 hertz. Further, what should be the inductance required to be connected in series so that it carries a maximum current? So maximum current carry गर्ने situation the inductor र capacitor को केसमा के हुन्छ भन्दा simply resonance को केस हुन्छ। resonance मा inductance र inductance को reactance, क्यापासिटीको रियाक्टेन्स इक्वल एन्ड अपोजिट भयो भने म्याक्सिमम करेन्ट क्यारी गर्छ। त्यसैले यहाँ हामीले के गर्नु पर्यो भन्दा म्याक्सिमम करेन्ट क्यारीको लागि फर म्याक्सिमम करेन्ट impedance will be minimum, and impedance will be minimum when there will be like your XL will be equals to XC, and XL equals to omega L, यो L हामीलाई निकाल्ने छ, अनि XC भनेको चाहिँ 1 by C अनि ओमेगा। ओके, सो यो अब रिजोनेन्सकै केस हो, हामीलाई ओमेगाको भ्यालु निकाल्न 2 pi f युज गर्छौं हामी। ओके, सो यहाँबाट सिम्प्लिफाई गरेर राख्ने हो भने वी क्यान इजिली क्याल्कुलेट। सो जस्तो यसलाई भनौं, सो 1 by ओके L क्याल्कुलेट गर्नु छ भने लेट मी जस्ट राइट L इक्वल्स टु हाउ मच 1 by 4 pi square। okay, 4 pi square, this is 2 pi f, and this is again 2 pi f. okay, here f is square and c. So if you just simplify, then the order of this inductance I have calculated is the order of 0.36 into 10 to the power minus 3 Henry, that is in the order of millihenry. Okay, so let us move on to another question, question number 5. Okay, so in here this is the LCR circuit, and in this LCR circuit some of the information are given to us, that is R equals to 100 ohm. Okay, and connected to 200 volt, this is VRMS equals to 200 volt, and the angular frequency means this is F. okay, so 300 radian per second. So actually this is not a frequency, rather omega. Okay, angular frequency is our omega, 300 radian per second, when only a capacitance is removed. Okay, some information are even in different way. Okay, the current lags behind the voltage by 60 degree. Okay, let me just write theta 1 equals to 60 degree, current is lagging there, and when the inductor is removed, the current leads by 60 degree. Okay, theta 2 equals to again 60 degree. Calculate the current and power dissipated in the circuit. Current and power we have to calculate. To calculate these two information, हामीलाई यो थीटा दिएको छ, यो थीटा को हेल्प बाट हामी निकाल्छौं, अदरवाइज this is going to be a bit difficult. So सुरुको केस हेरौं है, सुरुको केसमा हामीलाई के भनेको छ भने when capacitor is removed. Okay, capacitance is removed. When capacitor is removed, what will happen is the circuit is LR. Okay, LR. Then के हुन्छ त LR सर्किटमा हो भने हामीलाई थाहा छ, then 10 phi LR सर्किटमा 10 phi भनेको कति हुन्छ, XC by this is XL by R. Okay, this is your LR circuit, XL by R. Okay, so now this gives us XL equals to XL को भ्यालु त हामीले थाहा हुन्छ, R times 10 phi. R कति छ, R को भ्यालु हामीलाई 100 छ. okay, so 10 phi यो सुरुको केसमा 60 डिग्री भनेको 100 into √3 ohm. okay, similarly अब हामीलाई दोस्रो सिचुएसनमा के दिएको छ त भन्दा inductor removed. When again, so when inductor is removed, the circuit is CR. Then हामी कति लेख्न पाउने, 10 phi. हामीलाई त इन्फर्मेसन त 5 मा मात्रै छ, अब यता यहाँ थीटा 2 भनेको थियो है. okay, you may say let's write this is phi 1 and let's say this is phi 2, so 10 phi 1, so 10 phi 1. So for our easiness we wrote this XC by R. Okay, so this is another information. So यसलाई सिम्प्लिफाई गर्ने अनि यहाँबाट कति आउँछ XC इक्वल्स टु फेरि 10 5 to 60 डिग्री नि छ √3 into 100 ओम. सो यो दुईटा इन्फर्मेसन आयो. त्यसै गरी हामीलाई सर्किटमा करेन्ट निकाल्नु छ भने त हामीलाई इम्पिडेन्स चाहिन्छ. सो now the total impedance. Okay, total impedance in circuit. Okay, so let me just write impedance Z equals to how much? हामीलाई थाहा छ LCR मा R square plus XL minus XC को square. Okay, so यति हुन्छ. यसको रुट लगाइदिने यसरी हामी निकाल्न सक्छौं. सो यसरी निकाल्ने हो भने हामीलाई थाहा छ यो XL र XC को भ्यालु बराबर भयो. बराबर हुने बित्तिकै R square को रुट will be equal to R. So this is our 100 ohm. R को भ्यालु आयो है. Okay, now the remaining information let me just write in here. So अरु के गर्न सकिन्छ भन्दा हामीलाई IRMS निकाल्नु छ. IRMS means VRMS divided by Z. So VRMS को भ्यालु हामीलाई थाहा छ 200 by 100 is equals to 2 ampere. Okay, and power equals to IRMS को square times फेरि R. So यो भ्यालु यहाँ छँदैछ. R को भ्यालु फेरि 100 छँदैछ हैन. So if you just substitute these parameters, so I have calculated I square to 4 into 100 400. Okay, this is 400 watt. Okay, so this is how we can do the simple calculation for this one. Okay, let me move on to another, that is question number 6. Okay, so हामीलाई यहाँनेरि केही इन्फर्मेसन्सहरु दिएको छ. We will be listing out the information. So त्यसपछि हेरौं अनि के कुराहरु हामी यसबाट सिम्प्लिफाई गर्न सक्छौं. Okay, so let me move on in here. So for this one, an electric bulb is designed for 80 volt DC. Okay, so this is a given to us. Okay, so 80 volt. So volt DC, let me just write this way. DC is 80 volt. Okay, and the current flows. So IDC, let me just write for this one. So it is 10 ampere. Okay, and calculate the inductance of the choke required to run the bulb. Okay, so VRMS equals to 100 volt and the frequency is 50 hertz. हामीलाई अब यो DC मा चल्ने बल्ब छ है. अब यसलाई AC मा चलाउनु छ भने हामीले के गर्नु पर्यो भन्दा यसमा जति रेसिस्टेन्स छ हैन, यो बल्बले जति रेसिस्टेन्स अफर गरेछ त्यति नै रेसिस्टेन्स मेन्टेन गर्ने गरेको हामीले इन्डक्टर राखिदियौं भने है, Z को भ्यालु चाहिँ टोटल इम्पिडेन्स को भ्यालु चाहिँ 80 हुने गरेको इन्डक्टर जोड्दियो भने त र हामीले यो बल्बमा यो DC पास गर्दा जति रेसिस्टेन्स आएको छ त्यति नै रेसिस्टेन्स हुने गरी इम्पिडेन्स बिल्ड अप गर्न सक्यौं भने त यो बत्ती बल्छ है. त्यसैले अब हामी सुरुमा के गर्छौं भन्दा let us calculate the value of resistance of the bulb. So resistance of bulb. So resistance of bulb is going to be like your R equals to VDC by IDC. Okay, so you simplify when this is going to be simply 8 ohm है, यति हुन्छ. अब यसपछि हामीले के गर्नु छ भने यसलाई AC बाट रन गर्नु छ. AC बाट रन गर्नु छ भने यसमा हामीले के मेन्टेन गर्नुपर्छ भन्दा जुन इम्पिडेन्स थियो, इम्पिडेन्स डिजाइन्ड इज टु बी 10 ohm. Okay, so 10 ohm इम्पिडेन्स हामीले बिल्ड अप गर्नु छ. त्यो 10 ohm इम्पिडेन्स बिल्ड अप गर्नको लागि के गर्नु पर्यो भन्दा okay, this is your 8 ohm. Okay, so यहाँनेरि हामीलाई थाहा छ this is going to be run with 100 volt and 50 hertz. Okay, so यहाँनेरि हामीले हेर्यो भने हाम्रो टोटल रेसिस्टेन्स, यो हाम्रो केसमा टोटल रेसिस्टेन्स जुन यो 100 ओम ले दिनु पर्ने हो है यो 100 भोल्टमा रन हुँदा 100 भोल्टमा रन हुँदा टोटल इम्पिडेन्स यो 10 कसरी आउँछ भन्दा इट्स सो सिम्पल टु क्याल्कुलेट सो हामीले यो 100 भोल्टमा रन गर्ने सरी 100 भोल्टमा रन गर्दाखेरि हाम्रो करेन्ट चाहिँ कति हुनुपर्छ त सो यो यहाँनेरि रन हुने करेन्ट चाहिँ यो 10 भयो है 10 भयो सो 10/10 इक्वल्स टु 100/10 इक्वल्स टु 10 ओम सो इम्पिडेन्स हामीलाई कति चाहियो त 10 ओम चाहियो हैन सो इम्पिडेन्स 10 ओम हुनको लागि हामीले एउटा इन्डक्टर जोड्नु छ त्यो इन्डक्टरले कसरी काम गर्नु पर्यो भन्दा इम्पिडेन्सको स्क्वायर विल बी इक्वल्स टु रेसिस्टेन्सको स्क्वायर प्लस एक्सएल को पनि स्क्वायर यो हुने गरी गर्नु छ सो यो हाम्रो भ्यालु कति छ भन्दा यो जेड को भ्यालु हामीलाई थाहा छ यहाँ 10 हैन सो आर को भ्यालु 8 आयो भर्खर यहाँनिर हामीले निकालेको छौं 8 प्लस दिस इज 2 पाई एफ अनि यो एल को स्क्वायर सो सबै इन्फर्मेसन त हामीलाई छँदै छन् हैन सो इफ यू जस्ट सिम्प्लिफाई all this information then finally we can obtain the value of L to be so यसको पनि अर्डर चाहिँ 0.02 हेनरी जस्तो हुन्छ है सो यहाँनिर झुकिन सक्ने सम्भावना हुन्छ है जेड को भ्यालु चाहिँ कति हुन्छ त भन्दा जेड को भ्यालु चाहिँ यो 100 भोल्ट सँग एसोसिएट हुन्छ है ओके सो दिस इज व्हाट द solution for this one let me move on to question number 7 okay so in this question so AC source of angular frequency omega is feed across resistance R and a capacitor C in series okay there are two things एउटा ओमेगा छ यहाँ फेरि फ्रिक्वेन्सी कति गरेको छ omega/3 okay there are two frequencies so यो दुईटै केसमा but maintaining the same voltage the current in the circuit is found to be halved okay यो गर्दाखेरि सर्किटमा करन्ट हाफ भयो भने so calculate the ratio of reactance to resistance at original frequency so यो केसमा चाहिँ यो R र C ओरिजिनल फ्रिक्वेन्सी ओमेगा हुँदा यसको रेसिस्टेन्स र रियाक्टेन्स अनि हामीले निकाल्नु पर्यो XC/R को भ्यालु so let me just write with at frequency omega यस्तो हुने बेलामा हामी के लेख्न सक्छौं भन्दा simply XC equals to 1/C omega okay so यति त लेख्न सक्छौं हामी so यो बेलाको करेन्ट कति हुन्छ भन्दा करेन्टको भ्यालु हामीले निकाल्न सक्ने भयौं करेन्ट यो हाम्रो CR सर्किट भयो CR सर्किटमा करेन्टको भ्यालु हुन्छ VRMS डिवाइडेड बाइ R स्क्वायर प्लस यो XC को स्क्वायर विथ रुट अब त्यसैगरी अर्को फ्रिक्वेन्सीमा हेर्ने भने है सो अर्को फ्रिक्वेन्सीमा हेरौं एट omega/3 एट फ्रिक्वेन्सी omega/3 अरु त केही चेन्ज छैन हैन यस्तो हो भने therefore XC let me just write X dash okay X dash will be equals to how much this is also going to be I dash okay so 1/omega/3 so omega dash C okay so this is XC so if this 3 goes off so XC dash will be equals to 3/omega XC okay so फेरि यहाँनेर हेर्ने हो भने okay 1/omega dash C so 1/omega C भनेको फेरि XC देखिन्छ है so यहाँबाट सल्भ गर्ने हो भने XC dash will be equal to 3XC okay because this is 1/C omega 3 लाई छुटे राख्ने हो त 1/C omega नि omega XC नै हो है सो यति भयो त्यसो भए यहाँनेरि करेन्ट कति हुने भयो त लेट मी जस्ट राइट I dash सो I dash ले लेख्ने हो भने सो VRMS त सेम नै हुन्छ हैन VRMS डिवाइडेड बाइ यो कति हुने R स्क्वायर प्लस अब यो 3XC भनेको यो 9XC को स्क्वायर है सो यति हुने भयो अब यसलाई सल्भ गर्न चाहिँ सिम्पल म्याथमेटिक्स हामी युज गर्छौं म यहाँनेरि सल्भ गर्दिन सो दिस इज इक्वेसन 1 दिस इज इक्वेसन 2 ओके सो हामीलाई थाहा छ I र I डिवाइडिङ इक्वेसन 1/2 गर्ने नि डिवाइडिङ इक्वेसन 1/2 ओके सो डिवाइडिङ इक्वेसन 1/2 गर्ने के हुन्छ त भन्दा यो I छ. Okay, this is not I dash, rather this is I only. Okay, so I by I dash will be equals to all this VRMS divided by R square plus X square root. अब यो डिनोमिनेटर को माथि जाने है. So R square plus 9x square with root divided by VRMS. So यो भ्यालु पनि मलाई थाहा छ I अनि current is going to be half भने है. So is half. So current half भयो भने I can simply write this I dash will be equal to I by 2. Okay, so यसलाई on solving these equations. So यो I काटिने अरु काटिने हैन. So यो काटिने त्यसपछि यो VRMS काटिने. So यो रुट लाई हटाउने अनि यो 4 हुन्छ है. On solving we are going to get this XC by R निकाल्ने हो भने चाहिँ this is simply going to be equal to 3/5 आउँछ है. यसलाई मैले सल्भ गर्न छोडे because I need to shorten the video. Okay, this is going to be so long. Okay, let us move on. Okay, current 4 ampere. Okay, flows in the coil connected to 12 volt DC. Okay, so voltage again, this is similar to the previous one, 12 volt. Okay, and the current flows. Okay, let me just write IDC. So this is your what 4 ampere. So यो केसमा म resistance निकालिहाल्ने. Resistance equals to 12/4 means this is 3 ohm. Okay, you might get confused. So this is okay 12/4 equals to 3 ohm. Okay, यदि मैले निकालिहाल्ने. अब अरु इन्फर्मेसन म खोज्दै जान्छु. Okay, so connected to a 12 volt 50 radian AC source, the current is this much. Okay, अब current को भ्यालु अर्कै भयो. अघि यहाँ DC current यति थियो. So AC current कति छ त I AC equals to 2.4. किनभने I current AC current फरक पर्छ किनभने इम्पिडेन्स को कुरा छ. यहाँनिर हाम्रो coil छ. coil ले चाहिँ हाम्रो रिएक्टेन्स बिल्ड अप गर्छ. त्यो current को भ्यालु फरक पर्ने भयो. Okay, and you're connected to a 12 volt. Okay, VAC. So V let me just write RMS or something. RMS equals to 12 volt. Okay, and your omega is 2πf will be equals to so 50 radian per second. So all this 50 radian per second. Okay, so frequency flows this much. Determine the inductance of the coil. Okay, this is so interesting. अब हामीलाई निकाल्नु छ L को भ्यालु निकाल्न त्यति इजी छैन. L निकाल्न त हामीलाई इम्पिडेन्स चाहियो. इम्पिडेन्स को भ्यालु हाम्रो ZL सँग रिलेटेड हुन्छ. सिन्स IRMS is your how much VRMS divided by impedance. Okay, so you impedance side. So therefore Z equals to how much? This is your R square plus XL square. Okay, with root. Okay, R को भ्यालु हामीलाई थाहा छ यहाँनिर 3 ओम छ हैन. XL को भ्यालु यो चाहियो है. सो यो Z को भ्यालु निकाल्न हामी सक्छौं. Z कसरी निकाल्न सक्छौं भने Z is a kind of resistance. So resistance हो भने यो इन्फर्मेसन हेरौं. सो हामीलाई यहाँनिर यहाँ करेन्ट को भ्यालु दिएको छ हैन. करेन्ट को भ्यालु दिएको छ अनि त्यसपछि भोल्टेज को भ्यालु दिएको छ. सो यहाँनिर करेन्ट को भ्यालु दिएको छ, भोल्टेज को भ्यालु दिएको छ भने यसलाई सल्भ गर्ने हो भने Z is going to be how much VRMS divided by I. So यो सल्भ गर्ने हो भने कति आउँछ त हाम्रो how much is this? This is 12 divided by 2.4. This is your 5 ohm. Okay, so this is your 5 ohm. So यो पनि हामीलाई थाहा भयो. यो 5 त्यसपछि यहाँनिर R स्क्वायर भनेको 3 स्क्वायर प्लस 2 पाई को स्क्वायर into okay this is your omega. See, directly I can write this one is omega into L को whole square. सो यो त ओमेगाको भ्यालु मलाई थाहा छ सो यसको भ्यालु सब्स्टिट्युट गर्ने भने सो यो भिडियो छोटो बनाउनलाई म जम्प गरिरहेको छु अलिकति स्किप गरिरहेको छु सो यहाँबाट l को भ्यालु हामी निकाल्न सक्छौं यो आउँछ 4/50 ओके सो 4/50 लाई डेसिमलमा राख्ने 0.08 हेनरी ओके l को भ्यालु आउने बित्तिकै अब हामीलाई थाहा छ ओके सो अब हामी के गर्न सक्छौं भने हामीलाई निकाल्नु छ find the power dissipated in circuit okay पावर निकाल्नको लागि सो यो पावर डिसिपेटेड इन सर्किट निकाल्नको लागि हामी के गर्न सक्छौं भने यसको ओभरअल इम्पिडेन्स निकाल्न सक्छौं है ओभरअल इम्पिडेन्स निकाल्नलाई हामी के गर्छौं भन्दा सो वी नो वी have xl यो xl मात्रै कति हो त है xl इक्वल्स टु ओमेगा l l को भ्यालु हामीले भर्खरै निकाल्यौं त्यसैगरी एन्ड xc इक्वल्स टु 1/c ओमेगा c को भ्यालु पनि हामीलाई प्रोभाइडेड छ ओके त्यसैले देयरफोर z इक्वल्स टु अंडर रूट ओके कनेक्टेड इन सर्किट ओके सो कोइल यो जोडिसकेपछिको है यो अघिको यसको हाम्रो यो इन्डक्टरको मात्रै इम्पिडेन्स यो हो भने अब चाहिँ क्यापासिटर जोडेपछि लेट मी राइट z ड्याश सजिलोको लागि सो xl माइनस xc को यो होल स्क्वायर प्लस r square so if you do this you can easily get the value of overall resistance so the overall resistance पनि 5 ohm नै आउँछ किनभने सर्किटमा हुने ओभरअल रेजिस्टेन्सको भ्यालु त्यति छ है ओके सो यति आउँछ अब यहाँबाट ओके लेट मी क्याल्कुलेट द भ्यालु अफ करेन्ट ओके यहाँ कन्फ्युजिङ हुन सक्छ लेट मी जस्ट कीप हियर बार okay now we will calculate the value of current so IRMS equals to VRMS by Z dash okay so you can easily calculate this one so this is going to be 12/5 okay and so power will be equals to IRMS square into R so यो हामीलाई थाहा छ IRMS यहाँबाट निक्लेको छ यसको भ्यालु आउँछ नियरली 2.4 हैन इन्टु रेसिस्टेन्स ओके रेसिस्टेन्सको हामीले भ्यालु भर्खरै निकालेको थियो अगाडि सो दिस इज रङ ओके सो यसलाई सल्भ गर्ने हो भने दिस इज योर नियरली 17.3 वाट so this is how we can easily calculate the value of power consumed as well okay let us move on to question number 9 this is somewhat long one okay so peak voltage is 283 okay in this question peak voltage is given so p naught oh sorry peak voltage v naught okay v peak okay v naught equals to 283 therefore vrms will be equals to 283 divided by root 2 so if you just divide with 1.41 then I believe this comes 1.41 when I go 41 to the 84 this means in the order of 200 volt okay so vrms is 200 volt and then frequency equals to 50 hertz okay and then in LCR circuit containing resistor 3 ohm the resistor equal to 3 ohm and the inductor is your L equals to 25.48 into 10 power minus 3 Henry okay and this one C your C equals to 796 into 10 power minus 6 farad okay these are the information given to us now we have to calculate plenty of ideas okay so effective voltage we already calculated the effective voltage first one is finished okay now containing this inductive and capacitive reactance this is so simple so b number xl equals to 2 pi f into l everything is known to us and if you just multiply these informations will be known to you for example your 2 into pi means frequency 50. Sorry, 2 into 3.14. This is 50 into L is given. So you can easily calculate. This will come in some ohm. So XC pani kati huncha ta? This is so simple. 1 by 2 pi FC. You can easily get some ohm. Okay. Now in impedance of the circuit. यो LCR circuit. LCR circuit मा हामीलाई थाहा छ impedance भनेको XL minus XC square. Okay, this is actually whole square. Okay, so whole square plus R square. If you just simplify by keeping these two parameters that we have known previously, okay, यो value राख्ने हो भने हाम्रो impedance को value मैले calculate गरेको छु. It comes in the order of 5 ohm. Okay, now C, and next is D. D is a peak current. Okay, so peak current निकाल्नको लागि is quite simple. I naught. I naught means V naught by Z. So simple. V naught by Z. So this will come in the order of, I have calculated, this is 56.5. Okay, ampere. Next is peak current, the phase angle. So phase angle is 5. So 5 case my XL minus XC divided by R. So you can just substitute these values with 10 inverse. So this is in the order of 53 degree. You can just substitute the value. XL puncha, XC puncha, R pani dekhai cha hai. So E number सक्यो, F number. F number means I effective. Effective means RMS. So this is V effective, that is V RMS divided by Z. Okay. So if you substitute this effective voltage 200 volt divided by this 5. Okay, 200 by 5. So this is so simple. 200 by 5 means 4 into 40. Okay, 40 ampere. So peak current is high. Okay. Now next is Z number. Z number, effective voltage across the individual component. So you have to calculate like your VL. So VL equals to I times XL. So I means I RMS. Okay, and XL is already known to you in here. Okay, so XL, this is some voltage V. So VL and then VC. Okay, VC means I RMS into XC. You can easily do this as come some voltage. So VR, VR is also I times. So R, this is also some voltage. You can easily get. Okay, now next, power dissipated. Power dissipated means P equals to how much? IRMS. Okay, VRMS into cos phi. You can easily do this. Okay, so before that, power dissipated, again need power factor. Okay, so power factor, EFG as I number. Power factor is simply cos phi. So you can just write cos 53 degree. It will come some 0 point something and so. Okay, it is calculated. Is it in the order of 0.6? It doesn't have any kind of unit. Okay, you don't have to worry about that. A resonance frequency. Okay, a resonance frequency निकाल्ने हो भने हामीलाई थाहा छ the resonance frequency को formula F equals to 1 by 2 pi under root LC. You can simply substitute, and I calculated this. This is 34.5 Hz. Okay, further, power dissipated at resonance. Power dissipated at resonance means power maximum. किनभने यो हाम्रो resonance भएको बेला maximum power consume हुन्छ. यो भनेको I maximum है square into R. जहिले पनि resonance भएको केसमा power loss हुन्छ यो resistance बाट मात्रै, किनभने phase angle 0 हुन्छ. त्यो भएको हुनाले I square R लेख्छु र यो चाहिँ peak current हुनुपर्छ. Okay, so now we move on to the last question. Okay, Okay, so here a resistor is given to us 30 ohm, okay, and it is connected to a series with capacitance. Okay, capacitor is 79.5 into 10 to the power minus 6 farad. Okay, power supply of 50 hertz. So frequency is 50 hertz, and the voltage is VRMS is 100 volt. Okay, so find the impedance. So you need to calculate the impedance in the circuit. So this is your CR circuit. Okay, there is no L. Okay, so for CR circuit, Z equals to under root R square plus XC square. Okay, so to calculate XC, this is simple. R square plus 1 by omega C square. Okay, so you can easily get the value of this. It comes in some ohm. Okay, so current, you have to calculate current. So current is simply your VRMS divided by Z. So it comes some ampere. An equation for instantaneous current or voltage. So instantaneous current and voltage is like your VRMS equals to V naught sine omega t, or IRMS equals to I naught sine omega t. This is pretty similar to question number first. So we have to get I naught and we have to get the omega term. So your I naught equals to root 2 times I RMS, and your omega is simply 2 pi. So you can just substitute your, therefore I RMS will be like your root 2 I RMS into sine 2 pi f t. Okay, so this completes the discussion of these all. So we will be meeting again in another discussion. For today, I like to sign out. Thank you all.